Class 10, Chapter 1, Real Numbers, Exercise 1.2, Question number 3. Find the LCM and HCF of the following sets of integers by applying the prime factorization method. The sets of integers are 12, 15 and 21, 17, 23 and 29, 8, 9 and 25. Now, let us see how we can find the HCF and LCM of these sets of integers. When we write the sets of integers as a product of their prime factors, the HCF will be the product of the smallest power of each common prime factor in the numbers, whereas the LCM will be the product of the greatest power of each prime factor involved in the numbers. Let us have a look at the numbers given to us. The first set of integers is 12, 15 and 21. So, we will have to find the prime factors of all these numbers. The prime factors of 12 are 2, 2 and 3. So 12 can be represented as 2 square into 3. The prime factors of 15 are 3 and 5. So 15 can be represented as 3 times 5. 21 has the prime factors 3 and 7, and it can be represented as 3 into 7. The HCF is the product of the smallest power of each common prime factor in the numbers. The common factor from all these numbers is 3, and its smallest power is 3 to the power 1. So the HCF will be 3. Moving on to the LCM is the product of the greatest power of each prime factor involved in the numbers. The prime factors involved in the numbers are 2, 3, 5 and 7, and we must select their greatest powers. The greatest power of 2 is 2 square, so we take 2 square. The greatest power of 3 is 3 to the power 1, so we take 3. The greatest power of 5 is 5 to the power 1, so we take 5. And the greatest power of 7 is 7 to the power 1, so we take 7. On finding their product, we get 420. So the HCF of 12, 15 and 21 is 3, and their LCM is 420. Moving on to the next set of integers, which is 17, 23 and 29. 17 is a prime number itself, so the only prime number which can divide it is 17. Similarly, 23 is also a prime number, so the only prime number which can divide it is 23. And 29 is also a prime number, so the only prime number which divides 29 is 29 itself. There is no common prime factor in these numbers, and the only number which can divide these is 1, so the HCF will be 1. For the LCM, we have to select the greatest power of each prime factor involved in the numbers. So the prime factors involved in the number are 17, 23 and 29. So we will select the numbers 17, 23 and 29, and their product gives us 11,339. So the HCF of 17, 23 and 29 is 1, and the LCM of 17, 23 and 29 is 11,339. Moving on to the next set of integers, we have 8, 9 and 25. The prime factors of 8 are 2, 2 and 2. So 8 can be represented as 2 cubed. The prime factors of 9 are 3 and 3. So 9 can be represented as 3 square. The prime factors of 25 are 5 and 5. So 25 can be represented as 5 square. For the HCF, we have to find the smallest power of each common prime factor involved in the numbers. There is no common prime factor in these numbers, and the only number which can divide them is 1. So the HCF of these three numbers will be 1. For the LCM, we must select the greatest power of each prime factor involved in the numbers. The prime factors involved in these numbers are 2, 3 and 5. So we select 2 cube, 3 square and 5 square, which gives us the product as 1800. Therefore, the HCF of 8, 9 and 25 is 1, whereas the LCM is 1800. We have found the HCF and LCM of all the three sets of integers given to us.